So the first topic is fundamental concepts of engineering mechanics. Okay, let's have an intro. So first of all, engineering mechanics is the science which considers the effect of forces on rigid bodies. It's divided into two, statics and dynamics. So statics is just the effect and distribution of forces on rigid bodies, which are and remain at rest, while dynamics is the motion of rigid bodies caused by forces acting upon them. It's pretty self-explanatory from the names themselves, statics and dynamics. For our course, we're going to focus on statics. Okay, next. Let's have a few concepts and definitions. So first is rigid body. So rigid body is a term that you'll often hear for our course. So rigid body is a definite amount of matter, the parts of which are fixed in position relative to each other. So that's the formal definition. In layman's terms, a rigid body is just an idealization of a body that does not deform or change in shape. Okay, so that's an idealization. In actual, however, solid particles are never rigid. So they deform under the action of your applied forces. In many cases, however, this deformation is very small or negligible compared to the size of the actual body. Therefore, you can still assume that this body is rigid. An example of that is steel. Okay, so steel is considered a rigid body, even though it deforms, obviously, but the deformation is so small, it's negligible. Okay, next is force. So when we talk about force, we can talk about two things. It's either the external effect of a force or the internal effect of a force. So the external effect changes or tends to change the state of the motion of a body, while the internal effect produces stress and deformation in the body. In short, external effect is related to motion, internal effect is related to deformation. Okay? So by that sense, external effect is considered in engineering mechanics, while internal effects is related to strength of materials. Okay, which is a course that you might take in the future, strength of materials. So obviously for now, we're more concerned with external effect of force. Its effect on the direction or positioning of a body. So an example is to the right. Okay, so external effect, here you hit a baseball. So the external effect would be the direction, the trajectory of your ball, while the internal effect would be, as you can see, the actual deformation the ball undergoes. Again, this is in strength of materials, which is something we won't tackle. So you have three characteristics of force: magnitude, position of its line of action, and direction. So magnitude and direction self-explanatory. Let's talk about line of action. So line of action is used here in the principle of transmissibility. So it states there that the external effect of a force on a body is the same for all points of application along its line of action. What does that mean? Look at this drawing. So it means that no matter where your force is, as long as it follows a line of action, its effect on your body is the same. So example here, point of application is here. It's the same effect as having your point of application here. Even though this is technically a push and then this is a pull, the effect is the same. Same thing here. Okay, let's say your point of application is this side or this side. The total effect on your body is the same. Same thing here. As you can see, forces are applied at the surface. Its external effect is the same as forces applied at its center. Okay, so in the future, for example, this is your body, this is the illustration, and I drew it this way. Don't worry, it's the same thing. Okay, for external effect. However, the internal effect of a force is definitely dependent on its point of application. Okay, so internal effect, external effect are opposites when it comes to this. External effect doesn't care where you apply as long as it follows a line of action or the same path, in short. However, again, it's a different story for internal effect, since internal effect has something to do with deformation. Okay, and then next, we have your units. So units are usually this. We have a combination of English and metric system. So some examples are in English, some examples are in metric. So pounds, you already know that that's pounds. Kip. Now kip is something that you'll also encounter in the future. I've experienced in my other classes in strength of materials is something I also teach. Some of you or some of my students don't know what kip is. So right now, I'd like you to know kip is just 1,000 pounds, okay? And then ton is 2,000 pounds, and then grams is G, kilograms is 1,000 grams, okay? All right, so that is our concepts. Now let's talk about our actual force systems. So force system, it is any arrangement where two or more forces act on a body or on a group of related bodies. So we have several types of force systems, one of which is coplanar. So coplanar is when the lines of action of all the forces on a force system lie in one plane. So most of our examples will be coplanar, okay, meaning in one plane. So we won't discuss 3D setups yet. Okay, so all in one plane. And then under that, we have what we call your collinear force systems. So these are forces which have a common line of action. Later on, I'll show you an example. Next is concurrent force systems. These are forces whose lines of actions pass through a common point. You've seen an example of that earlier. Let me show it again. It's this. So as you can see, these three forces intersect here. So they are concurrent force systems. Next, parallel force systems, forces whose lines of actions are parallel. And then last, non-concurrent force systems, forces whose lines of actions are neither parallel nor intersect at a common point. And these are your examples. So collinear, as you can see, these group of people are pulling to this direction, and then this group is pulling to that direction. Their forces lie on a single line. So this is collinear. It doesn't matter if it's towards each other or opposite direction or same direction. As long as it's on the same path, they are collinear. Next, an example of a concurrent force system is your crane. So you have tension force here, tension force here, tension force here, intersecting here. So that's a concurrent force system. An example of a non-concurrent force system is your truss or roof trusses or your bridge. So you have a force along this member, a force along this member, essentially forces along each member. And all of them are neither parallel nor concurrent. So they're not all intersecting or not all parallel. Some of them are intersecting, some of them are parallel, but not all of them. That's why they are concurrent, non-concurrent. And then lastly, here, so weight is always downward. So if you have a collection of objects, for example, here, a collection of fruits, I believe, all of them have weight towards the center or towards or downward rather. So you have a collection of parallel force systems all downward for this example. Okay? So those are your real life examples of force systems. Now this is the sketch or representation of those systems. So as you can see, collinear along one line, concurrent, they are intersecting, non-concurrent, and then parallel. So we call this drawing actually as your free body diagram. So let's talk more about that. So again, these are free body diagrams. So what is a free body diagram? A free body diagram is just a sketch of the isolated body, which shows only the forces acting upon the body. So it is used to distinguish between action and reaction forces. So the forces acting on the free body diagram are the action forces, also called the applied forces. And then the reaction forces are those exerted by the free body upon other bodies. So in short, free body diagram is a sketch of forces, okay, as shown earlier. And then we have two types. First, you're going to draw the external forces, which are your applied or action forces. Then later on, you'll figure out the reaction forces. Okay. So I'm gonna teach you how to draw that, how to figure out what your reaction forces are in the succeeding lessons. Okay. So for now, that is the composition of your free body diagram. So a free body diagram may consist of an entire assembled structure or an isolated part of it. For example, here, this is your illustration. This is a free body diagram. This is also a free body diagram. So looking here, part C, we have a wire. So if you remember in your physics class, wires, or if it was mentioned, wires contain tension forces. So if you isolate this point, this is a pin. So isolating that, we have tension forces, then this is a reaction force. We have a reaction here. Okay, reaction, reaction, reaction. So this is an example of free body diagram of an isolation of point C. Another way to draw it is this way. As you can see, it included several members. So here, once again, you have your tension forces, your wires, and then you have your weight. So weight is an applied force, external force here. And then here at the top and bottom, they are fixed and they are experiencing your reaction forces. Okay, so reaction, reaction, tension, and weight. Okay, so this is an example of your free body diagram. Now, for those who are curious, so this setup is seen in real life, okay? And this setup is actually called a derrick. So derrick is a lifting device. So it's composed of guide mast, gin pole, and basically it's used or seen in ships and in docking facilities. Okay, so for those who are curious, what is this? All right, and that ends our introduction to mechanics. So of course we're not done. Okay, we're now gonna move to our lecture that involves problem solving. Okay, so let me just place it back. So before I move on to the next topic, do you have any questions? Okay, please answer yes or no. Do you have any questions? None, or what's your question?
None po.
None
None po,
naman.
ma'am.
Wala po, ma'am.
None po.
None po, ma'am.
None so far.
All right, great. So moving forward, I'd like you to prepare your calculator because you're gonna solve with me. Okay, so let me just fix our fix my class record because previously I believe you're only 14 in class during the first meeting and now you're like 40. So my class record is very outdated. Okay, so give me a minute to fix that. Okay. And So next topic is resultant of system of forces. So intro. So the effect of a system of forces on a body is expressed in terms of a resultant. So a resultant is just a single force obtained by combining a system of forces acting on a rigid body. So it determines the motion of a body. So for example, you got three forces, and then the resultant of that is a force towards the right. So therefore, the total effect of those three forces would move your rigid body to the right. Okay? So the resultant dictates the motion of your body. Now let's talk about the forces and its components. So first, we have this. So these are your equations for a force and given angle. So now let's discuss how we got those equations. So let's start a new file. Okay. So I've read your course expectations. Some of you were worried if I was gonna solve, and the answer to that is yes. You're gonna solve with me. Components of a force. Okay. Oops. So let's say we got a force here, right? Okay. What's your force? You have your theta. And then the goal here is to get your x and y components. So to draw your x and y components, it would be this way. By the way, I'm going to tell you now, this x and y components can be drawn wherever along the line of action of your force is. So it can be here, it can be here. It's the same thing, okay? I'm just going to draw it along the axis just to make things clear. So now that's your x and y. Now what if I do this? I project those components. Okay? You got yourself a right triangle, right? So that's a right triangle. So therefore, I can use concepts of a right triangle to figure out the x and y components.
Hello. Ay,
Okay, once again, you got a right triangle. And then, first of all, I'm looking for fx. Fx is this leg. I'm given theta. Therefore, this leg is adjacent to this. So I'm going to use cosine function since this is a right triangle. So if you use cosine, so remember the equation for cosine of a right triangle. Cosine is adjacent over hypotenuse. So adjacent to this is fx. And hypotenuse is actually your force F. It's over F. Therefore, F is just fx is just F cosine theta. Okay, and that's one of your equations. Now what about Fy? Well, let's use sine. So sine theta is opposite. This is your theta. Opposite of that is this, which is actually also the same as your Fy. So this is also Fy. Okay? So opposite over hypotenuse, again, it's F. So therefore, Fy is just F sine theta. And that's your other equation. Now, you can only use this equation if your theta is given along or with respect to the x-axis, okay? So this x-axis, y-axis. Next, what if I'm given components and I want to look for the total force F? Well, another thing, again, this is a right triangle. And another equation for a right triangle is your Pythagorean theorem. Pythagorean theorem is just hypotenuse squared equals base squared plus height squared. So you can use that. So once again, hypotenuse is your F. So F squared equals base squared, your Fx, plus height, which is again just Fy. So Fy squared. So solving for F, it's just Fx squared plus Fy squared. Okay, so that's one equation. Now what if I also want to know your theta? Once again, you're going to use your trigo function. If I'm given components, therefore I'm given opposite and adjacent, I can use tangent. So tangent theta equals opposite over adjacent. So opposite is Fy over adjacent Fx. And then therefore, theta is just arctangent Fy over Fx. Okay? So there, that is how those equations came to be. Right? Next, now what if I'm not given a theta, I'm given slope? Okay, so again, let's try to figure that out. Given slope. So once again, you have your F. We want to know your Fx and Fy. So this is your Fx, Fy. And then you're given slope. So usually slope, you're given rise and run, right? So let's name the run of your slope as H, and then the rise as V, okay? And once again, if you've noticed, this is a right triangle, and then this is, we'll call this R. So by the way, you can use any symbol you'd like or variable, I'm just calling it R. So this is a right triangle, therefore R is just square root of H squared plus V squared, okay? Now the reason why we're solving for R is because you're going to use that in your equation. So once again, looking at your illustration, this is a small triangle. And you also have this larger triangle. Since they have the same slope, okay, this and this, they're similar triangles. Okay, meaning you can use ratio and proportion. So ratio and proportion is just side over side equals side over side. Okay, so by ratio and proportion, since they are similar triangles, let's do that. So let's start with the larger triangle. Again, let's try solving for Fx first. So Fx, let's say base over hypotenuse. So base over hypotenuse. So Fx over F should equal the base over hypotenuse of your other triangle. So this is the other triangle, so base over hypotenuse. So equals H over R. So therefore, solving for F of X, that's just F times H over R. Okay? Do the same thing for Fy. So let's say Fy over hypotenuse again. So Fy over F equals the same thing here. This is height. So you're going to get the equivalent height of your smaller triangle. So this is the height over hypotenuse. Height is V over R. So therefore, Fy is just F times V over R. Now, one thing to remember though is your forces won't always be oriented this way. It could be oriented sideways or at a diagonal. So one thing to make remembering the equation easier is, take note of this, Fx is just equal to the total force F multiplied by parallel over hypotenuse. When I say parallel, that just means the side parallel to your component. So Fx parallel to that is H. So Fx is just F times H over R. Same thing with Fy. Fy parallel to that is your V. So Fy is just your F, total force F times V over hypotenuse R. Okay? So again, just remember whatever is parallel to that is what you're going to multiply to the total force and then divided by your hypotenuse. And that's the component of your force. And then, what if you have a system of forces, more than two forces? Well, first step is you're going to get all your forces F. all your forces along one component. So let's say Rx. So Rx is the resultant of all forces along the x-axis. So that's summation of Fx. Ry is just summation of Fy. So you're going to get the x and y components of each of these forces and take the algebraic sum of that. When you get Rx and Ry, you can now solve for the resultant using the Pythagorean theorem. R equals square root of Rx squared plus Ry squared. Okay? And then finally, similar to what we did in one of our derivations, to get the angle of your resultant, you're just going to use tangent theta equals Ry over Rx. And take note that theta is going to be from the positive x-axis, or rather just the x-axis. Okay? And this equation came from the tip-to-tail method or geographical method in solving for resultant vectors. Okay? So this is just shortcut of that. And so do you have any questions? Do you have any questions so far?
None so far po, ma'am.
Okay, good. Let's put this into practice. Let's have a few examples. Before we do that, by the way, we have sign convention here. Remember, we're taking the summation of forces x and y for resultant. So take note, forces to the left and downward are negative, forces to the right and upward are positive. Okay, so that's your sign convention. All right, let's start with examples. Number 1, a force of 200 pounds is directed as shown in the figure. Determine the x and y components of the force. Let's start with drawing that. And so 230. Let's start with effects. So since theta is given from the x-axis, I can use my equation. Fx is just f cosine theta. So that's 200 cosine 30. What's the answer? Oh, by the way,
170.
yeah, correct. You can just use the chat so that I can record who answered first. Okay? Because this counts as recitation. So correct 173.21. Not, oh, why did I type that? 173.21. However, this force is to the left. That's why it's negative 173.21 pounds. Okay. And then to specify, this is Fx, Fy. Fx to the left, that's why negative. Do the same thing for Fy. Fy is positive since upward. So Fy is F sine theta, so that's 200 sine 30, which is just 100. So correct, Andre and Arvin. De La Vega and Camilas. Someone's unmuted. Please mute. Thank you. Okay, so easy enough. Let's move on to number 2. Determine the components of the 300-pound force directed down to the right at a slope of 2, 3 as shown in the figure. So once again, let's draw. This is 300 pounds. And then my slope, scratch this forward. Let me just close. Um, Okay, sorry about that. My scratch disk was full. Okay, next. Slope. Slope is 2, 3. And as you can see here, you're given 3.61. Don't use that. You already know how to solve for r. R is just square root of 2 squared plus 3 squared. And 2 squared plus 3 squared is just square root of 13. So use square root of 13 instead. Okay? So now solving fx to the right, therefore positive. Yeah. So that's just f times h over r. So that is 300 times 3 over square root of 13. And the answer to that is your correct. Skylar and Jan, Nicole, 249 point, sorry, no, it's 249.62. So correct, Nicole and Dominic. So Taurus and all. Okay. Huh. Okay, you're not in my class record. Ayun pala. Taurus. Taurus. Yo. Okay. So again, that was 249.62. I'm gonna write that here instead. Okay. And then do the same thing for Fy. Fy is downward. Right? If you draw the components. This is Fx, this is Fy. So Fy is downward, so that's negative. F times V over R. So negative 300 times V. What's parallel to Fy? That's 2. So times 2 over square root of 13. And the answer to that is correct. Jade and Erwin, 166.41. For negative 166.41 pounds. Okay? So again, Simon and Navarro. Simon. Navarro. Oh. Okay. Next, number 3. Determine the x and y components of the forces shown. Now we have a combination of forces, and we're just looking for the x and y component of each. Okay. Okay, so once again, let's draw. We'll just push this upward. Okay. So we got F1, F2, F3, F4. And then 58, 50, 45, 40. 58, 50, and we're at kilonewton. Okay. Then 30, 45. 512. 512. Okay, so first things first, finding out the hypotenuse of this. So r is square root of 5 squared plus 12 squared, and that's just 13. So that's 13. All right. So x and y component of each. Let's start with x components first. Okay, let's start with F1. So f1x, I'm not going to write the equation anymore, okay? I'm just going to go straight to the solution. So f1x is just positive since to the right, so positive f, which is 58. And all of my angles are from the x-axis, so I can use cosine. Then cosine 30. Yes, it's 50.23. Sino na una? Jade and Leon. Okay. 50.23 kilonewton. Jade and Leon. L. And then, madali yun. Okay. So from this point, for this problem, I'm just going to give you the answer since this is just repetition of what we've been doing, okay? So you can solve along with me, making sure you get the same answer, okay? So let's continue. f2x is to the left, so negative, then 50 cosine 45. Negative 50 cosine 45 is negative 35.36. Yes, correct. You are correct. And then f3x is again to the left, so negative value is 45. And then we're looking for x, so side that is also along the x-axis or x component, which is 5. So 45 times 5 over 13. So 45 times 5 over 13 is negative 17. Yes, correct. Negative 17.31. And then lastly, f4x is just to the right, and it's not at an angle, so it's just 40 kilonewton. Okay? And then last, yes, correct, it's 40. Next, y component. So f1y, upward, therefore positive, so positive 58, sine 30. And what's 58 sine 30? That's 29. Very good. Yes, 29. And then f2y, it's upward again, so positive 50 sine 45, and that's 35.36. Yes, you are correct. Now, if you've noticed, f2y and f2x are the same magnitude or value, 35.36, and that is because the angle is 45. So yeah, that's just a property that it has. And then next, f3y, it's negative since downward, so negative 45 multiplied by, so this is fy, you're gonna get the component parallel to fy, so that's 12 over 13. So negative 45 times 12 over 13, that's negative 41.54. Yes, you're correct. 41.54. And then lastly, what's f4y? Correct, Angela and Justin, it's 0. Since there's no y component here. Okay? So that's the basics of getting your exponent, your components rather. Yeah. Do you have any questions for numbers 1, 2, and 3?
None naman po.
Okay, how about the others? Once again, you can just use the chat if you don't want to use your mic. None.
None po.
Okay. Great. So, wala. Let's Move on to the next set of questions. Make things a little bit harder. So most of you are correct in your assumption in your course expectation that this is mostly physics. Yes, it is. That's why your diagnostic exam is full of forces, because that's the component of physics that we'll use a lot. Okay. But we're gonna apply it more in your profession. So number 4, the triangular block shown in the figure is subjected to the loads 1,600 and 600. If AB is 8 inches and BC is 6 inches, resolve each load into components normal and tangential to AC. Once again, let's draw first. Let's call this your PN, and that's 1,600 newtons. And then this is your P. Sorry, that's just P. This is your F, right? P, 1,600, F, 600. Is it Newton or pound? Pound, sorry, pound. Pound. And then AB is 8, BC is 6. ABC. A, B, C. This is 8. This is 6. Yep. Okay. And then our problem here is resolve each load into components normal and tangential to AC. So this is your AC. What does normal and tangential mean? It means parallel and perpendicular. So let's start with normal. So normal is perpendicular. So normal to AC meaning perpendicular to that. Okay, so if I draw it, perpendicular. So it's this component right here. Okay. And then tangential means parallel. So tangential would have this slope. So moving that here, something like this. Okay. So let me project those lines just that you can show what's the actual vector representation of that. Okay. And so this is once again your tangential. So let's call that PT. This is your normal. So let's call that PN. So this is what the components look like. Remember, if you're resolving into components, make sure your force is the hypotenuse of a right triangle. So as you can see, I got right triangles here. Okay. Let's do the same for F. So F, that is your tangential, right? Parallel. And then normal would be perpendicular. And then let's extend those or project. Okay. So once again, this is tangential. So this is FT, and then this is FN. Now, if you're used to doing this, you don't have to draw it this way. You can just do it like that and know that this is PT and PN. Okay, that's fine. I'm just doing it this way so that you know the accurate representation of your vectors. Okay. So now what's the next step? Now I need to know the slope of my forces. How? By relating it to what's given. So this is a right triangle. And usually whenever you have a right triangle, I'm going to look for its hypotenuse. So let's solve our, this is just square root of 6 squared plus 8 squared, and that is just 10. Okay, so 10. Now how do I transfer that slope here? By doing it this way. Okay, so we're going to use a concept or the concept of perpendicular angles. So if two angles are perpendicular, that means the angle between them are equal. So in short, let's do it this way. So this line, let's use a different color. So this line perpendicular to this line, right? And this line is perpendicular to this line. Therefore, angle between them is the same. Okay? So we can say this is your angle, the same. So what's in front of this? It's 6 inches. So therefore, whatever in front of this, it should be 6 inches as well. Therefore, this is 6. Okay? So that is what that means. So this is your 6. Therefore, the other leg is 8. The hypotenuse is 10. So drawing that into slow form to make things a bit easier. Okay? So once again, this is your 6, right? Your other leg now is 8 and the hypotenuse is 10. Remember, your force is the hypotenuse for this case. Well, let's do that for the other force. Let's look for two perpendicular angles. So this line, perpendicular to this line, perpendicular to this line. Therefore, angle between them is the same, this and this. Okay? Angle in front of this is 8. So therefore, angle in front of this should be 8 as well. So this is now 8. So removing that, once again, that's 8. So transferring that into your slope. So this is your 8. Therefore, the other leg is your 6. And then again, this is your hypotenuse 10. Okay? So that is your vectors. Now you can easily solve for the normal and tangential using your equation. So let's start with P and Pn. So remember what I said earlier. If you just want to get the component using slope, that is just the total force P times whatever is parallel to that. So we're looking for Pn. Parallel to that is this leg, so it's 8. So times 8 over hypotenuse 10. Okay? So let me just write. Yep, it's 1 to 800. Yep. Sino nauna? So correct, Nicole and Carla. So Taurus and Batum. Okay. Now, what about the sign? Earlier, our sign was left downward negative up to the right positive, but that does not follow here anymore. So what you can do, for example, the question is looking for direction. You can just write or draw the vector used. So it's this way, so that's just this. Okay? Yun lang. Next, tangential, same concept. So it's the total force, 1,600. This is your PT. What's parallel to that? It's the 6. So times 6 over 10. And the answer is 960, yes. So Jade and Angela. Yep. So Simon and Garing. CG. Okay. And once again, follow the vector. It's upward. Do the same thing for F. So Fn, total for 600. Yep. So some of you already know, which is great. So 600 times Fn, it's this, parallel to that is 6, so times 6 over 10. The answer is 360. Sino nauna? 360. De La Vega, and Andre, and oh, Jermaine. De La Vega and Borbe. D. Right? Yep. Yep. All right. And so it's 360. And once again, direction downward. And then lastly, 50, 600 times t. It's this. So parallel to that is this, and that's 8. What's the answer? Kathleen and Nicole. So Castillo and Torres. So yes, it's 480. Okay. And once again, direction is this way. Okay, very good. So that's number 4. Next, let's move on to number 5. So 5. The body on the 30-degree incline in the figure is acted upon by a force P inclined at 20 degrees with the horizontal. If P is resolved into components parallel and perpendicular to the incline, and the value of the parallel component is 1,800 newtons, compute the value of the perpendicular component and that of P. So we're looking for P and its perpendicular component. Okay, let's try to draw that first. So this is 30 degrees. A box here. And, and then I got a force here. Let's use this. Okay, so this is my force P, and then this is 20 degrees. Okay, and so that's your given. Another thing that's given is parallel component is 1,800 newtons. So let's just note that. Let's use this as parallel, 1,800 newtons. So remember, this means parallel, this means perpendicular. Okay, and so parallel. So parallel and perpendicular to the incline. Okay, and to the incline. So that means, let's try to draw that for you to better visualize. Okay, there. So that's your parallel and perpendicular. So obviously this line is parallel to your incline, so this is your P parallel, and then this is your P perpendicular. So my goal is to find out P and P perpendicular, and I'm given this. So usually you're gonna work with what's given. So now I just need an equation for P parallel so that I can use this given. So how? Look here. Get P parallel. I'm given angles. So now my goal is to either know this angle or this angle so I can use sine or cosine to figure out what P parallel is. However, this is what I'm given. What you're gonna do, you can stare at your drawing and figure out what are your equivalent angles. Okay. So if you created an easy to understand drawing, you can easily see what your equivalent angles are. Okay. So knowing that, can anybody tell me what is this angle? What's the value of that angle? Correct, Arvin and Dominic, it's 30. So kanlasan on. Kanlas. So why? Why? How did that become 30? Look. Because they are alternating interior angles. This is parallel to this. So let's say I extended this line, right? So this angle is equal to this angle since they're the same line. And this angle is equal to this angle since they're alternating interior angles. Okay, remember your geometry or solid mensuration, wherever this concept was discussed, or trigonometry. Okay, again, they're equal because they are parallel angles or alternating interior angles. Okay, meaning horizontal, horizontal, and sharing the same slope. Okay, so they are alternating interior angles. So this is equal to this. Okay, so that's why they're both 30. Yun. Similar to your perpendicular angles. So now that I know this is 30, I can now figure out what this angle is. Can anybody give me what's that angle? Correct, John, it's 40. P. No. 40, how? Again, this is a right triangle. Therefore, sum of interior angle is 180. This is a right triangle, so 180 minus 90 minus 20 minus 30, that's your 40. Okay? Okay. So now I have my drawing. Now I can solve for P, parallel, and perpendicular. So let's just zoom out a bit and create our equations. Okay, so P parallel is now, looking at my drawing, this is my P parallel. So therefore it's this. So it's adjacent. So it's P cosine 40. Oh wait, is it? Oh no, sorry. This is my P parallel. And therefore this is the P parallel, also equivalent to this. Therefore it's opposite. So I'm using sine P sine 40. So 1,800 equals P sine 40. Please solve for P. What's the answer? Yeah, correct, Dominic. Make sure your calculator is in degrees. So who got that first? Dominic and Carla Batun. So Ong and Batun. Ong, Batun. It's 2,800.30 newtons. Now what I'd like you to learn, not only to make sure your calculator is in degrees, is to learn how to use the store function of your calculator. Because we want to store this. Now you can just look at your manual, look at the internet, because we don't have the same calculator, so I don't know how to store in yours. But I'm using a Casio FX 991ES Plus. And to me, to store, I'm just gonna click Shift, then Stop or Store. Then I'm gonna choose a letter. If you've noticed in your calculator, mine has 8 to F and then M and then XY. So let's say 8. So now this value is stored in 8. Okay. And then, for example, you want to use it, you're going to use alpha A. Okay. So try to study how to use your store function of your calculator in case you still don't know. Okay, now I have P. I want to get P perpendicular. So P perpendicular, look here. It's this. So it's adjacent to your angle 40. So I'm going to use cosine. P cosine 40. And yeah, you're going to use the full value of P. Using the full value of P, please solve what's P perpendicular. Okay, correct Jermaine and Angela. So if you use the star function, you're gonna get 2145.16, not 15. Okay, so who was that? Jermaine and Angela. So Borb and Darren. Okay. Okay. There. So that's number 5. And I don't think Kasha finds 6. Okay. So do you have any questions for numbers 4 and 5?
None po. Wala po.
Wala naman po.
None, ma'am.
Okay, great. We can move on to the next set of questions. So 6. Mhm. 6. So 6 in the figure, the x component of the force P is 140 pounds to the left. Determine P and its y component. So it's pretty similar to your number 5. Okay. So this is P 7474. And then what else? X component of the force is 140 to the left. So write that out. X component 140 to the left, so that's negative 140 pounds. We're looking for P and the Y component. So this is your PX, this is your PY. Right. So let's solve. Again, we're given PX, so I'm gonna use that. Or most likely I'm gonna use that. So create an equation for PX. So before that, I need to know what's R. R again is just square root of 7 squared plus 4 squared, 65. Yep, it's square root of 65, correct? So square root of 65. Yeah. And once again, px. Px to the left, so negative. So negative p. And then what's parallel to that, it's 7. So times 7 over square root of 65. So therefore, negative 140 equals negative p times 7 over square root of 65. What's p? Okay, sino Carla and Dominic. It's 161.25. Batoon and Ong. Elemento. Batoon. Ong. No. Yung. This is it's 161.25. Now, why are you getting 1 to 1.55, it's because you typed in your calculator 140 times 7 over square root of 65. To solve for P, it's 140 times square root of 65 over 7. Okay? Or 140 divided by 7 over square root of 65. Okay? So make sure you type in your calculator correctly. That's why you're getting 1 to 1. So it's 161.25. And then in the same manner, store that value. We're gonna look for Py. So Py is just P times what's parallel to Py, it's 4 over square root of 65. Correct. Ano to? Andre and Dominique, so De La Vega, I know. It's 80. Flat 80. Yeah. Okay. So that's it. That's just your number 6. Next, last 3. Let's move on to number 7. Compute the value of the resultant of the concurrent forces shown in the figure. So previously, we've been solving for components only. Now we'll move on to solving for the actual resultants. So let's draw. So I got a force there, another force here, another force here, and then here. This is 100 pounds. This is 300 pounds. This is 200. And this is 400. And then 1, 2. Oh, wait, angle 60, 45, 30. 1, 2. So once again, first step, solve for R. Square root of 1 squared plus 2 squared. And that's just square root of 5. So right, square root of 5. Okay, so we're looking for resultant. Remember, to solve for resultant, I need Rx and Ry first. So let's start with Rx. Rx is just summation of forces X. Okay, so the choice of your forces are arbitrary. You can choose whichever force you want to solve first. So let's say I use this first. Okay, so 100 pounds, X component to the right, therefore positive. So positive 100. And then the X component, whatever is horizontal, the leg that's horizontal, so that's 2 over hypotenuse square root of 5. Okay, then choose your next force. Again, this is arbitrary, up to you, the organization of your forces. So let's say I'm going to choose this next. It's to the left, therefore negative. So negative 300. Then this is X component, so cosine. Again, you can only use this equation if your angle is from the x-axis. Okay, all of these are from the x-axis, so it's fine. So negative 300 cosine 60. Next, this is also negative, so negative 200 cosine 45. And then lastly, this is to the right, so positive 400 cosine 30. Please solve. What's the answer? So correct, Nicole and Kathleen. So Torres and Castillo. Torres, LHIJK University. Torres. Castillo. It's 144.43. So for those who got an incorrect answer, please recheck. Okay, so store that. Okay, because we're gonna use that. Store. Do the same thing for Ry. The summation of forces y. That is, let's start again here. So upward, therefore positive 100 times 1 over square root of 5, since 1 is also vertical. Next here, it's upward, therefore positive 300, and then this is y component, so sine 60. Next, this is downward, so negative 200 sine 45. And then again, this is negative downward, so negative 400 sine 30. What's the answer? Correct, Skylar and 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 oh sorry. Yeah, Skylar and Kathleen. Negative 36.89. So Dupra and Pamatmat. Dupra. Ang dalawa din pala Kathleen natin. Pamatmat. Okay. So this is negative 36.89. And again, store. And now, what you're gonna do to get R, that's just square root of Rx squared plus Ry squared. What's the answer? This your Rx, your Ry. 149.07, correct? So that is Jade and Jermaine. So Simon and Borg. Okay. Now we're not done. Whenever you're looking for resultant, you also have to solve for theta. So theta is just arctangent Ry over Rx. Now make sure you're getting the absolute value. So ignore the sign of your Ry and Rx when you're inputting your value or using your value. So it's, who got it first? Eliana and Dupra. Yeah. All right. Okay. So Dupra and Domingo. Okay. Dupra and Domingo. Okay. It's 14.33. Now that's not done. We need to get the direction. So to get the direction, look at your Rx and Ry. Rx is positive, so meaning your Rx is to the right. Ry is negative, meaning downward. So combining that, the direction is down to the right. Now sometimes you're gonna use bearings. So in bearing form, this is south of east. But for now, just use down to the right. Okay? So that's your number 6 and 7. Any questions so far?
None po.
Wala po, ma'am.
Okay, great. And then let's move on to the last question for today, I believe, since we don't have much time. Number 8. Okay, number 8. Forces F, P, and T are concurrent and acting in the direction as shown. Find the value of F and alpha if T equals 450 newtons, P equals 250 newtons, and beta equals 30 degrees, and the resultant is 0. So let's first draw. So I got these forces. This is T. We're looking for T and alpha. And then these are given, or rather F. 450 to 50, 30 newtons. Correct? 30. Beta 30. Okay, so we're looking for F and alpha. And then look here. Resultant is 0. Resultant is 0. That means Rx is 0 and Ry is 0. Okay? That's what resultant 0 means. So now I'm going to use these equations to solve for F and alpha. Let's start with Rx. So Rx is 0. So let's create an equation for Rx. That's just summation of forces x. Once again, choose your force. Let's start here. F. F is to the right, therefore positive. So positive F, this is x component, so cosine angle is alpha. Next, let's choose this one, again to the right, so positive 250 cosine 30. And then you got this, so minus 450. And that's equal to 0. And let's call that your equation number 1. Okay, since I got nothing to solve here. Next, let's use the other one that's given, your Ry equals 0. So Ry equals 0. So again, let's start here. So F, positive since upward, so F, Y component, so sine alpha. This is downward, therefore negative 250 sine 30. And this doesn't have a Y component, so that's just 0. And then equals 0. Okay? And then if you can see, I can rewrite this. F equals 250 sine 30, transposing this to this side, over sine alpha. Okay, I got two equations, two unknowns, therefore I can solve for this using simultaneous equations. So let's call that equation 2, and let's sub it in equation 1. Okay, so subbing this into equation 1, you get 250 sine 30 over sine alpha, right? Then times cosine alpha, and plus 250 cosine 30 minus 450 equals 0. And now we can just solve for alpha, but let me try to simplify this further. So look here, we got cosine alpha over sine alpha. That means that's cotangent alpha, right? Okay, and then I can equate this to transposing these two terms to the right. 450 minus 250 cosine 30. And then cotangent alpha is just 450 minus 250 cosine 30 over 250 sine 30. And now solve for alpha. Please solve. What's alpha? Correct, Carla. It's 28.16. And Skylar, a mathematics. Batoon and mathematics. Yeah, it's 28.16. So 28.16 degrees, that's alpha. Next. Now we can sub that into this equation. So sub into, what's the answer? We're looking for F. So what's F? Correct, Mark and Aliana, 264.85. So Domingo Villamor. So once again, 264.85. And unit, Newton. Okay, that's number 8. Any questions for number 8?
None po.
All right, so no questions. So next meeting, we're going to solve number 9, and then we're going to continue with a new topic, moment of a force. Your next meeting is Thursday, I believe. So first period would be lecture, second period would be seat work, and then next week, Tuesday, would be your quiz number 1. Okay. Also, for those who aren't here or weren't here during our first meeting, we had our orientation. First of all, as a reminder, do not message me in Facebook. Okay, Facebook messages will be ignored. Instead, please just message me in Blackboard. I check that from time to time. Okay, so don't worry about that. Unless it's really urgent, okay? And then I've uploaded your course orientation file under lectures in your Blackboard. So please read that in case you have any concerns and it could be answered there. I also uploaded a recording of your course orientation. So please watch that as well. Okay, now for those who haven't answered their diagnostic exam, please send me an excuse letter via course message explaining why you haven't. You have until Thursday to take your diagnostic exam. Okay, you have until Thursday. So please send it to me as soon as possible. For those who did not send any excuse letter, your attempt for the diagnostic exam will not be counted. Yeah. Okay. So once again, send me an excuse letter for your diagnostic exam. Then we'll schedule when you can take your diagnostic exam. Deadline is Thursday. Okay, so send me ASAP. All right. Do you have any concerns? Also, you can message me here on Blackboard for any concerns as well. Sorry, in Zoom meetings for any concerns. Okay. So, do you have any more concerns? Yes, this is recorded. And I'll upload it and send the link to you later. Okay, let me show you. Yeah. Zoom recordings. As you can see, orientation is already uploaded, and later on I'll upload the one for this meeting. Okay, anything else? How about the others? Okay na?
Okay na po.
Alright. Okay. So once again, yung mga hindi na-diagnostic exam, send me excuse letter, then we'll schedule your exam. Okay? Since you don't have any more questions, see you next meeting. You may go. Goodbye, class.
Right po, ma'am. Thank you.
Thank you po, ma'am.
Thank you po,
Thank
ma'am.
you po, ma'am.
Po, ma'am.
Thank you po, ma'am.
Thank you.